Older Further Stranger, Episode 10, The Zen of Erectus, Chapter 1, The Cave. The hills west of the Jordan are limestone, and limestone dissolves, so the country is full of holes. Most of them are dry and small and hold nothing at all. A few held people for 250,000 years, and one of those is below you now, a dark mouth in a slope of scrub oak and red soil with thin smoke coming out of it. It's late afternoon. 4 figures are coming up out of the wadi with something heavy slung on a pole between them, moving at the pace of people at the end of a working day. One of them shifts the weight on his shoulder, and the others slow for him, and then everybody picks it up again. Somebody down by the water straightens, turns, and points at something further up the valley, and 3 heads come around to follow the arm. From up here, they're completely ordinary. That doesn't survive the walk down. At 100 meters, the scene holds. At 50, the proportions start to bother you without your being able to say why. Shoulders too wide for the height, necks thick, everyone built heavier than the job seems to require. At 20, it goes all at once, and it goes at the head. A single unbroken ridge of bone runs across the brow where you have 2 eyebrows. The skull behind it is long and low and travels backward instead of rising. There's no chin. The jaw comes forward and stops. Inside the cave, the animal is being cut up, and it's being cut up in a sequence, the same cuts in the same order as last time, which we know because the marks on the bones from these sites fall in consistent patterns, and a shared procedure means a shared understanding of how the job goes. The fire is in the corner where the fire always is. Somebody is napping flint near the entrance where the light is better. This is Kisum Cave, 400,000 years ago, 12 kilometers from what's now the Tel Aviv airport. Chapter 2, Where They Were. The animal in the cave is called Homo erectus, and the first thing to get hold of is how much that name is being asked to cover. Something recognizably of this kind is in East Africa around 2 million years ago, the Turkana Basin on the Kenya-Ethiopia border, Olduvai Gorge in northern Tanzania, which is where the record is thickest because the rift keeps stacking lake mud and volcanic ash in alternating layers, and ash can be dated. The youngest fossils anybody has managed to date are from Nandong, a river terrace in central Java, and that date has had a violent history. In 1996, a team led by Carl Swisher ran electron spin resonance on animal teeth from the site and got somewhere between 53 and 27,000 years, which would have put Homo erectus alive in Java while modern humans were arriving in the neighborhood. It was a spectacular result, and almost nobody believed it because the teeth they dated couldn't be securely tied to the layer the hominins came from. Russell Seoshon and Kira Westaway spent years going back to the terrace itself, dating the sediment rather than the fauna, and in 2020 published a figure between 117 and 108,000 years. The overlap evaporated. What survived is the point that matters. Even at the later date, they were still there long after our own species existed. Between those 2 points is a run of roughly 1.75 million years. Our species has managed 300,000. Theirs went about 6 times longer. In generations, at 25 years each, we've had around 12,000. They had something near 70,000. The spread is harder to hold than the duration. The oldest hominins found anywhere outside Africa are at Dmanisi in the Republic of Georgia, on a promontory between 2 river gorges under the ruins of a medieval town, 5 individuals in volcanic ash, 1,850,000 years ago. What they carried was Oldowan, simple flakes and choppers, nothing like a hand axe. They walked out of Africa before the hand axe existed. Everything leaving Africa on foot goes through the Jordan Valley, which at that latitude is about 70 kilometers wide. Ubeidiya, just south of the Sea of Galilee, at 1.5 million years, has the oldest hand axes outside Africa. Gesher Benot Ya'aqov, a few kilometers north, at 790,000. Kasem, the cave from the opening, at 400,000. 1 million years of occupation in a strip of land you could drive across between lunch and dinner. Then Java, where the record runs from something over 1.5 million years at Sangiran, down through Trinil to Ngandong, roughly 1.4 million years of hominins on one island, the longest continuous regional occupation documented anywhere on Earth. One caveat that gets dropped and shouldn't be: there is no ancient DNA from Java. None ever, because heat destroys it. That continuity is read off morphology and stratigraphy. It isn't demonstrated. China, Zhoukoudian outside Beijing, the Peking Man caves, between about 780 and 400,000 years, and Yunxian in the Han River Valley, which Christopher Bay's team redated using cosmogenic nuclide burial dating to about 1.75 million years, some 600,000 years older than the site had been held to be. That method runs on a clock that starts when a rock gets buried. Cosmic rays hitting quartz at the surface make aluminum-26 and beryllium-10 at a known ratio, and once the quartz goes underground and gets shielded, the two decay at different rates, so the ratio tells you how long it's been down there. The result is new enough that it may not hold. If it does, central China and the Caucasus were occupied at effectively the same geological instant, 6,000 kilometers apart. 80,000 years separates those two dates, and the error on dates that old runs to 100,000 years or more, so nobody can say which came first. 80,000 years is around 3,000 generations. Spread 6,000 kilometers across 3,000 generations, and you get 2 kilometers a generation, which is what any large mammal does when the next valley is empty and nothing in particular is pushing. Robin Dennell and Will Roebucks made that argument 20 years ago against the standard account of a dispersal out of Africa. There was no exodus and no frontier. Animals fill the habitat in front of them, and Eurasia was habitat. Europe was different, and Europe kept failing. Atapuerca in northern Spain from about 1.4 million years. Happisburgh on the Norfolk coast at around 900,000, 52 degrees north, the latitude of Saskatoon, where Simon Parfitt's team found footprints and flakes in estuarine silt in a landscape of boreal conifer with no sign of fire. That footprint surface was gone within a fortnight. The tide took it, and what survives is photographs and casts. Boxgrove in Sussex at 500,000, Schöningen in Germany at 300,000. Nick Ashton and Simon Lewis have shown British occupation across this whole period is discontinuous. People arrive, the climate turns, the record goes quiet for 100,000 years. Somebody arrives again. Nobody held the north. And two places no drift into empty habitat explains. Flores and Luzon lie east of a line of deep water that has never closed at any sea level, however far the ice pulled the oceans down. Stone tools on Flores by 1 million years ago, and on the same island much later, the small-bodied Homo floresiensis, announced in 2004 and immediately contested, with a senior Indonesian paleoanthropologist arguing the type specimen was a modern human with a growth disorder, an argument that ran for a decade and lost on the anatomy of the wrist and the shoulder. At Kalinga on Luzon, 709,000 years ago, a rhinoceros skeleton with 57 cut marks on it and the limb bones broken open with hammerstones, published by Thomas and Gicko's team in 2018. The body is what makes a range like that possible. The most complete early skeleton is a boy who died beside a marsh at West Turkana 1.5 million years ago, found by Kamoya Kimiu in 1984. Long legs, short arms, an arched foot, bone thicker and denser than ours all through. For 20 years, he was reported as a giant. The original estimate had him reaching something over 6 feet as an adult, and that number went everywhere. The tall, striding hunter of the savannah, built for running down game on the open grass. Then Rhonda Graves and colleagues reworked the growth estimates, allowing for the possibility that this animal did not grow on a modern human schedule, and the adult stature came down to around 5'4". The picture went with it. He wasn't a giant, he was a compact, heavily muscled adolescent of about 8 who had been aged at 11 or 12 until Christopher Dean's team counted the daily growth lines in his tooth enamel and found he'd been growing faster than a modern child. Neil Roach showed the shoulder was set up to store elastic energy and release it into a thrown object, the anatomy of throwing, which no other primate has. In 2009 at Illoret, across the same lake, a team scraped back silt and found footprints of that age with a modern arch, a modern roll from heel to ball, and a big toe lying alongside the others instead of splayed off to the side. The walking was finished and finished in the form we still use. Above the neck, the container strains. Brain volume across the span of the name runs from about 550 cubic centimeters at Dmanisi, barely past a chimpanzee, to something over 1,200 in the late Javanese material, which is inside the modern human range. And the 5 Dmanisi individuals, one population, one hillside, one moment, differ from each other by more than the differences used elsewhere in this field to justify separate species. David Lord Kipanidze published that in 2013. Milford Wolpoff and colleagues had already published a paper titled The Case for Sinking Homo Erectus, arguing the name should be dissolved into our own. Ian Tattersall and Bernard Wood argued the opposite. New names keep getting proposed at the edges, Joluensis, Bodoensis, and keep getting contested. That's what happens when a 19th century filing system meets a 21st century sample. Chapter 3, the hand axe. Across nearly all of that duration and all of that geography, they made one thing. A stone worked on both faces, roughly symmetrical along its length, size to a hand, brought to a point or a rounded tip at one end. The Apulian hand axe, named for a gravel pit at Saint-Achel in northern France, where the first ones were recognized in the 1850s. The oldest come from Kokesele in West Turkana at 1,760,000 years, published by Christopher Lepre's team. Konso in Ethiopia is statistically indistinguishable in age. The youngest are maybe 150,000 years old. In between, they turn up from the Cape of Good Hope to the gravel terraces of the Thames, from the Atlantic coast of Morocco to Tamil Nadu. The eerie part isn't that they're similar. It's that they're similar at that range. A biface from Somerset, one from the Vaal River, one from the Narmada Valley, laid out on a table together, are the same object with local accents. Nothing else made by any animal has that distribution. It changed slowly. Early pieces are thicker and cruder, later ones thinner and better finished. There are regional accents, which Stephen Lysett has demonstrated statistically. Prepared core techniques show up alongside the old form toward the end. What's remarkable is the rate. A design appears in the Rift Valley, and 1,000,000 years later, people on another continent are still working inside it. For most of the last century, that rate got read as a verdict on the mind behind it. A creature that made the same thing for 1.5 million years couldn't improve, couldn't accumulate, couldn't teach properly. The verdict arrived before the animal did. In 1868, Ernst Haeckel published a family tree of human descent with a hypothetical intermediate in it, which he named Pithecanthropus allelus, the speechless ape man, and had drawn by an illustrator. No specimen existed. He reasoned it into being because a gap implies something to fill it, and then he put it on a ladder between the gibbon and the man. A Dutch anatomist named Eugène Dubois read this, resigned his post in Amsterdam, enlisted as a medical officer in the colonial army specifically to get himself to the tropics, where he was convinced the thing would be found, and in 1891 produced a skull cap from the bank of the Solo River in Java. A femur turned up the next season, 15 meters away, looking much more modern. He put them together and called the animal Pithecanthropus erectus. Whether that femur belongs with that skull cap has been argued about ever since. Current opinion leans toward it being intrusive from a younger layer, which would mean Dubois' critics were right for the wrong reasons, and that pairing is the type specimen, the physical anchor of the entire species. So the latter preceded the bone by 23 years, and the latter has outlasted most of what's been dug up since. But exposing a prejudice doesn't dissolve a fact. The rate is real, and it wants an account. Chapter 4, Reading the Tool. A kitchen knife is a wedge of hard material with a handle on one end. It's been that since the Bronze Age, and it'll be that tomorrow. The fork on your table and the fork on a medieval European table are the same instrument. The sewing needle, a shaft with an eye in it, shows up in the archaeological record around 40,000 years ago and has never been improved on, only manufactured differently: the rope, the nail, the hinge, the bowl. Whole categories of thing arrive at a form and stop and stay stopped straight through the invention of writing and agriculture and metallurgy and the steam engine and the internet, because the form is right and there's nothing further to want from it. Nobody looks at the persistence of the knife and concludes the people using it couldn't think. The persistence of a solved thing isn't evidence about the solver, it's evidence about the problem. That doesn't settle the hand axe, it changes the question. Instead of why didn't they improve it, the question becomes what got solved so completely that 1.5 million years turned up no reason to leave the solution, and the answer to that is more interesting than the tool. Because a hand axe isn't really a shape, it's a system. A block of good stone carried across a landscape works as a store of edges. Each strike detaches a flake that's razor sharp the instant it separates, sharper along the working edge than surgical steel, gets used within the hour and gets thrown away. The block travels, it gets worked again wherever an edge is wanted, it thins, it gets dropped when it's too small to strike from. Stephen Kuhn calls this provisioning the individual rather than the place. The toolkit is the rock in your hand, and the working is centripetal. You go around the circumference, alternating faces, each circuit taking material off the perimeter, while the object keeps its proportions and shrinks. The same operation repeated at descending scale. The flakes that come off can themselves become cores for smaller flakes. The system nests inside itself, which means the biface is a rechargeable edge, a portable, renewable, self-similar answer to the problem of always having something sharp in a world with no shops, no caches, and no way to know what tomorrow is going to require. Read that way, the persistence isn't a failure to innovate. It's what a correct answer looks like from the far end of a very long time. The deflationary school has been arguing something close to this and drawing a colder conclusion. On Kuhn's account, the elegant piece in the museum case is the exhausted end of a sequence rather than its goal, and Shannon McFerrin tested that directly, measuring refinement against degree of reduction and finding the two track each other more closely than refinement tracks time or region. The most beautiful ones may just be the most used up. I.A. Davidson and William Noble named the general error the finished artifact fallacy, reading intention into whatever shape a process happened to stop at, and Harold Dibble had already run the equivalent demolition on Mousterian scrapers, showing that a whole typology of named tool types was better explained as stages in the resharpening of one tool, and the symmetry may cost nothing. Alternate the faces to keep the working edge at a usable angle, work around a large flake blank as the material demands, and rough bilateral symmetry falls out of the procedure without anybody wanting it. There's exactly one reading that would genuinely diminish the makers, and it's the only one that would. That reading is instinct, that the biface is a fixed action pattern built in like a spider's orb web or a weaver bird's nest, complex, beautiful, standardized across a species and a continent and requiring no thought at all. Several things stand against it. The regional patterning Lycett found isn't what a fixed pattern produces. Instincts don't have dialects. At Ubeidiya, there are 150 limestone spheroids. Antoine Muller's team put them through spherical harmonic and surface curvature analysis in 2023 and found the objects become markedly more spherical through reduction without becoming any smoother, with curvature uncorrelated with how much material came off. Percussion doesn't converge on a sphere by accident. Something was being worked toward, and it wasn't a hand axe. From the gravels at Cuxton in Kent come bifaces 30 centimeters long and 2 kilograms in weight, too large to use and considerably harder to make, recurring wherever the raw material allows. Anna Machine, Rob Hosfield, and Stephen Mithen tested symmetry against actual butchery performance and found no advantage, so whatever the symmetry was for, it wasn't cutting. And at Olduvai Gorge, published in 2025 by Ignacio de la Torre, Renata Doyon, and colleagues, 27 tools napped from elephant and hippopotamus limb bone at 1.5 million years. Bone fractures on entirely different rules from chert. The crack runs differently and the material gives. A napping technique that shows up in bone got carried there on purpose by somebody who understood what the technique was for and adapted it to a substance that doesn't cooperate. Instincts don't transfer across materials. And the elephant bone was chosen preferentially despite being harder to come by, which is a decision about material properties made by somebody who had no business knowing anything about material properties. So the object is several objects at once, a system for carrying sharpness, a tool, a byproduct, and occasionally something made to be looked at in different valleys and different hands, sometimes in the same century. 150 years of increasingly refined analysis has made the most studied artifact in prehistory more ambiguous rather than less. Chapter 5, The Sites. The evidence that these people were doing more than the stone suggests comes almost entirely from places where something other than stone made it through. There are very few of those, and each one exists by accident. Ubeidiya is standing on end. The deposits went down flat on a lakeshore, and then the Dead Sea transform. The fault system running the length of the Jordan Valley got hold of them, and the beds are now tilted 60 to 80 degrees, in places nearly vertical. Somebody excavating a single occupation surface there isn't digging down through time. They're digging sideways along a wall. Moshe Stekalis started work in 1960. Ofer Bar Yosef and the paleontologist Eitan Chernov carried it for decades after. Chernov's faunal work gives you the country, a warm lake margin with woodland and open grass around it, straight-tusked elephant, hippopotamus, 3 species of deer, a giant buffalo, horse, gazelle, wild boar, and on the other side of the ledger, saber-toothed cat, a giant hyena, bear. The animals that could eat you are as well represented as the animals you could eat. It also mixes African species with Eurasian ones, which is what a corridor looks like in a fossil assemblage, a place where 2 faunal provinces overlap because animals are moving through in both directions. The hominins are one line item on that list, moving with everything else. That list is the landscape, though, not the menu. Most of that bone got into the ground without a hominin anywhere near it. Carnivore kills, animals dying at the water, a lake margin doing what lake margins do. The hominin-modified fraction of the assemblage is small. What the people at Ubeidiya were actually eating is close to invisible, and it stays invisible until you get to a site where the ground held on to something softer than bone. 13 kilometers north it did. Gesher Benot Ya'aqov sits on the margin of another lake in the Hula Valley, drained by tractors in the 1950s. Nama Goran Inbar's teams have worked it for 30 years. The deposits are waterlogged and got buried fast, so oxygen never reached them, and the result is the richest lower Paleolithic site on Earth, dated to about 790,000 years by argon dating combined with the magnetic reversal recorded in the sediment. The camp is organized, fish processed in one area, flint napped in another, nuts cracked in a third near the fire. Nira Alperson Afil's spatial analysis, published in the journal Science in 2009. There are 54 anvil stones with pits worn into them from cracking nuts, and 7 nut species identified, some edible only after processing, out of a plant diet running to 55 kinds of edible thing growing within reach of the shore: water chestnut, the seeds of the prickly water lily, wild olive, wild grape, acorns, the rhizomes of water plants, crab, turtle, waterfowl. There are over 40,000 fish remains, overwhelmingly 2 species of large carp, skewed toward big individuals. Somebody was taking the big ones on purpose. And 95% of what survives is the hard pharyngeal teeth from the back of the throat. Irit Zohar's team worked out why in 2022, the rest of the bone had been heated to below about 500 degrees. Hot enough to cook, not hot enough to destroy. The proof that the fish were cooked is that most of the fish is missing. Fire is the other thing this site settles, and it settles it in a particular way. Anywhere else, a scatter of burnt flint could be a brush fire that ran through the camp after everyone left. Alperson Afil mapped where the burnt pieces lay, layer by layer, and found them concentrating in the same spots, not spread across the surface, but pooled in one corner, and then again in roughly that corner in the layer above, and the layer above that. A wildfire doesn't come back to the same 3 square meters for tens of thousands of years. That's the strongest early evidence anywhere on Earth that somebody was maintaining a fire in a chosen place rather than encountering one. And because the ground was wet, the site kept the things that never keep: fragments of worked wood, worked bark, a piece of polished willow. Whatever these were part of has not survived, and every wooden object these people carried for 1.5 million years is otherwise gone from the record entirely. So a few centimeters of shaped willow from one waterlogged Israeli lakeshore is standing in for a whole technology. Add it up, and the significance of Gesher Benot Ya'aqov is out of all proportion to its size. One site on one lake at 790,000 years supplies the earliest well-argued evidence for controlled fire, for cooking, for organized use of space, for systematic plant processing, and for woodworking. Not because the people there were doing anything the others weren't, because the Hula Valley went anoxic and everywhere else did not. Kesem, the cave the hour opened in, is the young end of this, and it does something none of the others do. It shows the same corner of the same room being used the same way for tens of thousands of years. Ran Barkai and Avi Gopher have excavated it since the year 2000. There's a hearth near the center of the cave, used and reused across a span the excavators measure in the tens of thousands of years, with butchery concentrated around it and flint knapping happening somewhere else. Fallow deer come in as whole limbs and get cut up in a consistent order. Kesem also has flakes with two patinas on them, an old weathered surface with a fresh scar cut into it. Somebody found a piece of worked stone that had been lying out long enough to change color, recognized it as good material, and started working it again. Barkai's team has argued that this recycling is systematic rather than incidental. It's a small thing to look at and a strange thing to think about. An object outliving the attention of the person who made it and getting picked back up by somebody who never knew them. Both of those sites also settle an old fight. In the 1970s, Glenn Isaac proposed that the dense scatters at Olduvai were home bases, central places food got carried to and shared out at, which would imply provisioning and delayed consumption and some kind of division of labor. Louis Binford took it apart, arguing the same scatters could be produced by hominins scavenging at carnivore kills, with no transport, no sharing, and nothing social implied at all. That argument reset the field's defaults toward parsimony for a generation. A floor with discrete work areas, a hearth in a fixed spot returned to across strata, 54 nutting anvils, and carp selected by size and cooked is not what a scavenging model predicts. Kalambo Falls in Zambia. J. Desmond Clark dug there through the 1950s and 60s in deposits that have been permanently waterlogged since they formed and found worked wood. He understood exactly what he had. He couldn't date it. The methods available reached back 40,000 years, and the deposits were obviously older. So one of the most important organic assemblages in African prehistory sat in the literature for 6 decades as an undated curiosity, correctly described by a man who couldn't prove how old it was. Lawrence Barham's team went back, re-excavated, and put luminescence dating on the enclosing sediments. 476,000 years. 2 logs lying across each other with a notch cut where they meet so the two interlock, plus a digging stick, a wedge, and a chopped log. Oldest structural use of wood anywhere. Not a tool, but a joint. 2 pieces shaped to fit each other and make a third thing. No hominin bone was found with it. So who made it is inference. Schöningen, where an open-cast lignite mine cut through a buried Pleistocene lakeshore, and Hartmut team's team worked ahead of the machines. 8 spears of spruce, 300,000 years old, each thickest about a third of the way back from the tip, which is where a javelin balances, lying among the butchered remains of at least 10 horses. Boxgrove in Sussex, 500,000 years, excavated by Mark Roberts and Simon Parfitt in a working quarry on ground that was being sold off as they dug it. The site got buried fast by fine sediment under a chalk cliff, so the flakes lie where they fell, and they can be refitted, physically reassembled into the block they came from, which reconstructs one napper's single sitting on one afternoon around a butchered horse, with the cut marks lying underneath the carnivore tooth marks, which means the people had the carcass first. And from Trinil, the same Javanese riverbank that gave up Dubois' skull cap, a freshwater mussel shell with a zigzag incised into it while the shell was still fresh. 500,000 years old, published by Josephine Jordans's team in 2014, the oldest deliberate geometric engraving in the world by roughly 300,000 years. It means nothing anybody can name. It was meant. Chapter 6. What is missing? The other ledger is real and needs stating plainly. There are no painted walls, no figurines, no beads or pendants or worked ornament of any kind, no burial the field agrees on. Stone moves a few kilometers from its sources, where modern foragers routinely move it 100 or more, and long-distance stone is the archaeological fossil of a social network of debts and gifts and relatives over the horizon. Rot doesn't cover all of that. Ochre survives, beads survive, engraved bone survives. From about 100,000 years onward, those things get found readily, and before that, they essentially don't. Some portion of what's missing from this record is genuinely missing. The rest of it is a different problem, and the shape of that problem is the most useful thing in this hour. The archaeological record isn't a record of what people did, it's a record of what happened to survive. Stone survives indefinitely. Thick bone survives well. Tooth enamel survives better than anything. Wood, fiber, hide, sinew, bark, cordage, netting, gone within centuries unless something unusual intervenes. Every site in the last section exists because of an accident of hydrology or geology, a waterlogged deposit, a lake margin that flooded and sealed, a mine that cut the right layer with an archaeologist standing beside it, a chalk cliff that came down at the right moment. Across 1 3/4 million years, the record holds maybe 4 or 5 such windows. Call it one every 300,000 years. And in that handful of openings, structural woodworking turns up twice, at sites separated by 176,000 years and a continent. When a sample that thin returns the same capacity twice, the reasonable conclusion is that you're looking at something ordinary through a keyhole. The water crossings sharpen it. Flores and Luzon were reached, not in dispute. How is unresolved? Robin Donnell and Julian Lewis have argued for accidental rafting. Tsunamis tear vegetation mats off a coast with animals aboard. It's a real mechanism, it happens, and it would have to happen more than once onto more than one island, delivering enough individuals to found a breeding population. Robert Bednarik built rafts with period-appropriate tools and sailed one across the Lombok Strait, which establishes that deliberate crossing was physically available and nothing beyond that. No watercraft from the entire Pleistocene has ever been found anywhere on Earth. Not one. That includes the crossing to Australia around 50,000 years ago, which was certainly made by modern humans in boats, in enough numbers to found a continental population, and which nobody disputes. 50,000 years of undisputed seafaring and not a single vessel. The absence of Erectus boats is a fact about what water does to wood. There's a larger version of the same problem sitting under the Java Sea. At glacial low stands that sea wasn't a sea at all, but a plain the size of a subcontinent, with rivers running across it, and Java and Borneo and Sumatra were the high ground around its edges. It's been drowned for about 15,000 years. Sand dredging in the Madura Strait has brought up hominin material and butchered animal bone from those drowned valleys, the only substantial sample anybody has taken from the floor of that plain. A century and a half of Southeast Asian prehistory comes off the leftover highlands. The valleys where the water was, where the game came to drink and the sediment was soft enough to walk in, are 200 feet down. Chapter 7. Fire. Fire is where the story of steadily accumulating capability breaks down. At Wonderwork Cave in South Africa's Northern Cape, a tunnel running 140 meters into a hillside, Francesco Berna and Michael Chazan's team documented burnt bone and ashed plant material at about a million years, 30 meters in, well past where a lightning strike or a grass fire could reach. The method matters. They cut intact blocks of sediment, impregnated them with resin, sliced them thin, and looked at them under a microscope alongside infrared spectroscopy, which tells you what temperature a material was heated to and whether it's sitting where it burned. Chazan's more recent work reads still older traces at that site back toward 1.8 million, as fire collected off the landscape rather than made, embers gathered from a natural burn, carried in, kept alive. That deeper claim is new and contested and should be held loosely. And then there's Zhoukoudian, which for 60 years was the answer to this question and then stopped being one. The Peking Man caves were dug through the 1920s and 30s, and the excavators found dark layers meters thick, full of burnt-looking bone, which they read as hearth deposits, ash accumulated by generations of fires. It went into every textbook. Homo erectus controlled fire, and the proof was in a limestone fissure outside Beijing. In 1998, Steve Weiner and Ofer Bar Yosef went back with different equipment. Wood ash leaves a specific mineral signature, and in undisturbed hearths you find siliceous aggregates, tiny glassy bodies from the plant tissue that burned. They ran infrared spectroscopy through the sequence and the signature wasn't there. What they found instead was water-lane silt. The dark layers were sediment washed in, not ash built up. The burnt bone was real, but nothing showed it had burned where it lay. The most famous fire evidence in paleoanthropology came apart in a single paper. Later work by Zhang Xiaoqi and colleagues has put some of it back, arguing for burning in place in one part of the sequence, and the site now sits where a lot of this subject sits. Probably yes, not certainly, and the certainty of the textbooks was never earned. Then Happisburg, 52 North, boreal winter, no fire. Boxgrove, where the preservation is fine enough to reconstruct one person's afternoon, no fire. And thermally altered flint records heat regardless of what fuel was burning, which matters, because the standard objection is that these methods are calibrated for wood, lichen leaves almost nothing, dung leaves microscopic spherulites nobody was looking for. The flint doesn't care. At Boxgrove, it isn't there. Will Robrooks and Paula Villa surveyed the European evidence in 2011 and concluded habitual fire use only appears after about 400,000 years ago, which damages the most elegant theory in the field. Richard Wrangham's argument is that cooking is what made this animal possible. Pre-digested food paying for a smaller gut and a bigger brain. And it requires fire by roughly 1.9 million years. And at that date, the fire isn't there. Rob Hosfield has worked out what a northern winter without it would take. Autumn hyperphagia, marrow and brain fat, frozen carcasses staying edible for months, natural shelter, and probably abandoning the latitude every winter and coming back. So capability in this lineage didn't accumulate in a line. It flickered present in a warm African cave at a million years, absent 500,000 years later in a cold country that needed it far more. And there's a live control experiment for how much a fire culture can hide. Aboriginal Australians managed a continent with it. Bill Gamage's argument in The Biggest Estate on Earth is that the open park-like country the First Fleet recorded as wilderness was made country, held that way by burning regimes tuned to season and soil and vegetation, curating game and opening ground for food plants across tens of millennia. Rebecca Bleachbird has documented the working system among Martu people in the Western Desert, where patch burning measurably restructures what the landscape gives back. The archaeological signature of that immense system is faint. We know about it because the people who run it are alive and were eventually asked. Chapter 8, The Rate of Change. The rate still needs explaining, and what breaks the old explanation isn't a discovery about them, it's a discovery about us. 65,000 years ago in South Africa, a toolkit shows up that reads like a preview of everything modern. Small backed blades set into hafts with mastic, silkcrete deliberately heat-treated to improve its flaking bone points, engraved ostrich eggshell. It's called the Howison's Port. It runs perhaps 5,000 years. Then it stops, and what follows is simpler, and there's no agreed explanation for either end of it. The people involved were anatomically identical to anyone alive now. Sally McBurdy and Allison Brooks assembled the general version in the year 2000 in a paper titled The Revolution That Wasn't. The markers of modern behavior turn up piecemeal across 200,000 years of the African Middle Stone Age, appearing in one region, vanishing, appearing again somewhere else. Nobody woke up modern on a particular morning. And in the Levant, the same hills this hour started in, the material record sits close to still for 200,000 years, while both modern humans and Neanderthals passed through it. Once you've watched sophistication switch off in Homo sapiens, stasis stops being a diagnosis of a species and becomes a question about conditions. There's a literature on exactly that, none of it written about Erectus. Robin Torrance, working on hunter-gatherer technology, found that toolkit complexity tracks the cost of failure. Arctic foragers carry elaborate, specialized, meticulously maintained gear because a tool failing in the wrong week kills you. Tropical foragers carry simple, expedient kit because improvising again tomorrow is cheap. Intelligence is constant across that range. Risk is the variable. Peter Bleed drew the engineering distinction underneath it, reliable systems versus maintainable ones. And the principle is recognizable anywhere failure is catastrophic and there's no backup. Joseph Henrich argued that complex skills only ratchet upward when enough minds hold them across generations. So innovation rides partly on demography, and small isolated populations can lose techniques outright. Christ Weisen and Will Roebucks have contested that hard enough that it shouldn't be leaned on. None of this establishes anything about the interior of an Erectus head. What it does is remove the automatic inference. A slow rate of change is what small, scattered populations produce under stable conditions where a failed experiment costs more than it returns. Which brings back the knife. Fidelity across 70,000 generations stops looking like a ceiling somebody failed to break through. Our own species hasn't held a tradition intact for 5,000 years at a stretch. Chapter 9. The Teeth. The newest evidence in this subject didn't come out of the ground, it came out of storage. 6 teeth from Zhoukoudian outside Beijing and from 2 other Chinese sites, Hexian and Sunjiadong, excavated in the 1930s and after, cataloged, shelved. The original Zhoukoudian fossils were lost in 1941 while being evacuated ahead of the Japanese advance. What survives of those is Franz Weidenreich's casts. He documented as though he expected to lose the originals, and he was right. Fu Qiaomei's team ran the enamel of the surviving teeth through a mass spectrometer and got protein back, 400,000 years old and legible. The reason it's protein and not DNA is the edge of what this field can currently reach. DNA is a long, fragile molecule. It fragments with time and heat, and in warm climates, it's unreadable within tens of thousands of years. Proteins are shorter and tougher, and enamel is the hardest tissue in the body, so a protein sealed inside it lasts where DNA can't. The trade is information. DNA carries a genome. Protein carries a handful of amino acid positions. All 6 specimens share 2 variants of a protein called amyloblastin. One has been found in no other hominin ever sequenced, not at Dmanisi, not in Antecessor, not in Neanderthals or Denisovans or us. The other was already known from Denisovans. The Ice Age Asian population identified almost entirely from genetics before anybody had a face to attach to it, and it's present today in living people in Southeast Asia and Oceania. Fu reads gene flow. East Asian Erectus populations mixing into the Denisovan line, which later mixed into the ancestors of living Papuans and Aboriginal Australians. Christopher Bay reads simple descent, Denisovans as, in effect, a late East Asian branch of the same lineage carrying a family variant forward. The method establishes relatedness and can't establish direction. That isn't a flaw in the study. It's the boundary of what a few amino acid positions can say. The tree doesn't survive either reading, and it was already failing. Matthias Meyer's sequencing of the Cima de los Huesos material at Atapuerca 28 individuals at the bottom of a 13-meter shaft, 430,000 years old, every bone of it carried out by hand through several hundred meters of crawl since the 1980s, found Neanderthal nuclear DNA alongside Denisovan-like mitochondria in a single population. Living Papuans carried Denisovan ancestry from at least two source populations that had themselves been separated for more than 300,000 years. Alan Rogers's analyses find super-archaic lineages, populations splitting off around 1 million years ago with no fossil attached and no name, detectable only by the shape they left in modern genomes. What comes out of all that is a braid, populations spreading, separating for 100,000 years, meeting again, mixing, separating again, some strands running dry and some running on. Chapter 10. Older Mistakes. One more thing, and it isn't a discovery but a pattern in the discoveries. Marceline Boulay reconstructed the first well-preserved Neanderthal skeleton in 1911 as a stooping, bent-kneed, shuffling brute, an image that ran in textbooks for 50 years and owed a good deal to the individual having had severe arthritis. At Bruniquel Cave in France, Neanderthals walked a third of a kilometer into total darkness 176,000 years ago and built rings out of broken stalagmites. What for is unknown. That they did it is undisputed. Betty Meggers described Amazonia as a counterfeit paradise, whose soils were too poor to sustain complexity, and the forest has since produced geometric earthworks, engineered dark soils, and tree populations, whose distribution carries the signature of long cultivation. In the Kisadugu region of Guinea, colonial foresters recorded the dense woodland ringing each village as the last surviving fragment of a forest the villagers had destroyed. James Fairhead and Melissa Leach went through the aerial photographs and the oral histories and established that the villagers had planted them. Hallam Movius drew a line across Asia in 1948, separating hand axe makers from everyone east of it, and 2 generations of inference about East Asian mines followed, until Ho Yame's team published bifaces from the Bose Basin in Guangxi, dated by a tektite layer to about 800,000 years, sitting on the wrong side of it. This isn't a law of nature. The field has also produced Piltdown and Calico and a long tail of claims that shrank on inspection, and a flattering story isn't true because it flatters. But the underestimates are numerous. They cluster, and several of them were made about living people by trained observers, with the practitioners standing right there to be asked. Chapter 11. What We Can Say. The question that organized this subject for a century, were they clever, were they dull, where on the ladder do they belong, doesn't hold up. The ladder was drawn before the evidence. The vocabulary was built for sorting living human beings from one another, and there's no reason it should survive contact with an animal that ran 6 times our duration and did most of its work in materials that no longer exist. What can be said is narrower than a verdict and a great deal more than nothing. The camp on the lakeshore was organized by activity. The fire came back to its corner across generations. The fish were selected by species and by size and heated below the temperature that destroys bone. The nuts were cracked on 54 stones made for cracking nuts, several of the species inedible until processed. Logs were notched to interlock. Spears were balanced where a javelin balances. Elephant bone was knapped like flint by somebody who knew perfectly well that bone isn't flint. Limestone was worked toward a sphere. Open water was crossed more than once. And somebody at Trinnell cut a zigzag into a shell for a reason that hasn't survived. None of it converges on a verdict. All of it converges on a presence. That refusal to converge is the Zen in the title, and it belongs to us rather than to them. Nothing in the ground says they were serene. Nothing in the ground says anything about their inner life at all. What the title describes is the work of holding several readings at once, the fire and the places without fire, the carpentry and the unchanging design, the crossings and the silence about boats, each of them true somewhere, none of them forced into a ruling the instruments can't deliver. That is also the only honest way to face our own beginnings, which sit behind the same rotted materials, the same braided lineages, the same methods pushed to the same limits. They're the extreme case of a problem in which we're the near case, and each is the instrument for reading the other. Chapter 12. They had a long run, and how it finished isn't known, and neither is where. The youngest fossils anybody has dated are the Javanese ones at around 110,000 years. That's where the evidence stops. It isn't necessarily where the people did, and Java isn't the last place they were. It's the last place we've found. There's no ancient DNA from that island, and there never will be. The plain that surrounded it is under 200 feet of water. The Chinese Middle Pleistocene is a muddle of names that keep getting proposed and withdrawn. And the protein work suggests part of the answer isn't an ending at all, that one of their variants passed into the Denisovans, and from the Denisovans into people alive at this moment in Southeast Asia and the Pacific, carrying it without any idea that they do. Nobody was simply replaced. The absorption ran in every available direction for a very long time, and the question of when it stopped is a question about our sample rather than about them. The hills west of the Jordan are limestone, and limestone dissolves, so the country is full of holes. Below you, there's a dark mouth in a slope of scrub oak with thin smoke coming out of it, and four figures coming up out of the wadi with something heavy slung between them, moving at the pace of people at the end of a working day. The species stopped leaving fossils. Some fraction of it is still here.